So in this video we're going to be looking at the common functional groups used in organic chemistry. So this image right here shows us the functional groups that we're going to work with in our study of organic chemistry. The only three listed on here that are not actually functional groups are these three right here that should be very familiar to you: your alkanes, alkenes, and alkynes. These are actually homologous series. They're compounds with the same general formula. Everything else, your phenyl, your alkyl halide, amine, alcohol, ether, aldehyde, ketone, carboxylic acid, ester, and amide are all functional groups. So what functional groups are? They're an atom or a group of atoms that are going to replace the hydrogen atom in a hydrocarbon, and they're going to give the molecule its functionality or its reactivity. So let's take a look at how we're going to use these functional groups, because what you're going to need to be able to do is to pick these functional groups out of a larger molecule to identify and name these specific functional groups. So let's just do a couple for practice to see how these functional groups fit into a larger organic molecule. So let's take a look at this molecule. One of the first things you want to do when trying to identify functional groups is look at the molecule and identify any atoms or elements that aren't carbons or hydrogens. So right here, all of these chlorines stand out. So once you identify the atoms that are different other than a carbon or a hydrogen, what you need to do is follow those atoms back to the carbon that they're bonded to. So in this case, I'm going to start with this chlorine, and I'm going to follow it back to the carbon and see if the carbon is bonded to anything else. And it is, but the only other thing that it's bonded to is a hydrogen, and these little dots mean that this molecule is going to continue on in the same fashion. So it's bonded to another hydrogen and another carbon. So now I'm going to look up at my handy little table of functional groups, and I'm going to look for anything that has a Cl. Well, none of these groups have any chlorines, but I notice this right here that has a C and an X. And what that X actually stands for is a halogen, which includes fluorine, chlorine, bromide, and iodine. So chlorine is a halogen. So what this is, or what the functional groups are in this molecule, are alkyl halides, or we can actually just call them halides. So each one of these is a halide or an alkyl halide. So those are the functional groups present in this molecule. So let's take a look at another example. All right, let's take a look at this molecule. So what this little squiggly line means, it's actually just a shorthand way of writing a long carbon molecule or a long carbon chain. So at each of these points, there's actually a carbon molecule. It's just easier to represent it like this, but we know at each one of these points there's a carbon. So this is a 1, 2, 3, 4, 5 carbon chain with a 6th carbon at the end, which is attached to some things that are neither carbons nor hydrogens. So if I start with this OH and I take a look at this OH and I jump up to my functional group table, I can look for everything that has an OH. So I have an OH here and an OH here. So one common mistake is to see the OH and immediately name it an alcohol. But don't forget, what you need to do is you need to look at that potential functional group, the compound or the element that's different from carbon and hydrogen, and then follow it back to the carbon that it's attached to. So this OH is attached to a carbon, and is that carbon attached to anything else other than another carbon or a hydrogen? Indeed it is. It's double bonded to an oxygen. So that rules out my functional group of alcohol, because the carbon is not only bonded to an OH, but it's also double bonded to an oxygen, making this whole functional group carboxylic acid. Okay, so be sure you include or take everything that the carbon is attached to into account. So let's take a look at another example. All right, so let's take a look at this rather intimidating looking molecule. Well, the first thing I notice are these weird shapes in the middle. And what those are is those are actually aromatic rings. So there, remember our aromatics, there are carbon rings with alternating double bonds. This, drawing it with this circle in the middle, is just a common shorthand way of writing aromatic rings. So these are actually both aromatics, but as we talked about in the last video, we know that if we replace one of the hydrogens in this aromatic ring and attach another functional group or some other compound, some other elements, we are going to actually form the phenyl functional group. So in this case, both of these are my two phenols. So I have two phenyl functional groups. And I also notice, let's choose a different color, I also notice that I have some oxygens and nitrogens, which aren't carbon and hydrogen. So they must be part of another functional group. So I'll come up here to my table and I'll take a look for any functional groups with nitrogen. Well, I have amine and amide. Well, my amine has a carbon attached to a nitrogen which is attached to a hydrogen. That hydrogen can also be another carbon. So we can have a carbon, we can have carbons kind of sandwiching the nitrogen. So in this case, I take a look at my nitrogen and I follow it back down to its carbon, and its carbon that it's attached to is in fact attached to something else, which means it's an amide and not an amine. Theamine's carbon isn't attached to anything other than other carbons or hydrogens, but in this case the carbon is double bonded to an oxygen. So this is an amide. So we actually have multiple functional groups going on in this molecule. And then I look up here at the end and I actually have another amide. So it is possible to have multiple functional groups within a single molecule. So when identifying functional groups, remember, look for anything that is not a carbon or a hydrogen, and then follow it back to its carbon and see what else it might be attached to. If it's attached to something else, and especially look to see if that carbon is attached to anything else other than another carbon or a hydrogen, because that is going to dictate what functional group it is. Also take placement into account. So the ketone is always going to be on the center carbon, and an ether is going to be sandwiched in between two carbons. So take note of all the connections, all the bonds, and the placement of those elements as well.